Hi there. The following is a video over linear equations, and we're going to do an overview of this and cover a lot of material in one video. So the first thing I want to talk about is what is a linear equation? And that's an equation that represents a line, okay? And one of the things that we got to take into account when we're talking about linear equations is that the exponent above the 1, or I'm sorry, above the x is 1, okay? And that's something that I'll show you. Now, we've got three kinds of linear equations, or three forms, all right? The first we will call standard form, okay? And standard form is in the form of ax plus by is equal to c, okay? The other one that we have is called SlopeIntercept form. All right, and this one we've got y equals mx plus b, where m represents your slope and b is your y-intercept. Okay, and we'll talk more about these. And then the other one is called point slope form. Okay. And that's y minus y sub 1 is equal to m times x minus x sub 1, where m is your slope, and you have x sub 1 comma y sub 1 is a point on the line, or on your graph, however you want to say that, okay? So that's the idea, all right? That's what we've got, all right? So we've got these three forms here: standard form, slope-intercept form, point slope form. We will use all of these, okay? The first thing I want to talk about is identifying slopes given an equation, one of these equations. So in each of these examples, I just want to simply identify the slope of each line. Now, when I look at this, the slope, these equations are in slope-intercept form, meaning that I have y equals, and then some number times x, and then plus or minus some other number, okay? And so when we think of slope-intercept form, y equals mx plus b, slope is always in front of the x value. So if I were to identify the slope in this equation, my slope would simply be 1/3. All right, if I wanted to identify the slope in the second equation, it's the number in front of the x, and our slope here would simply be 2. Now, if you're given equations in standard form, meaning that x and y are on the same side of my equal sign, then what I want to do is I want to transform these and turn them into slope-intercept form. And I do this by solving for y, okay? So in any time you see this, we can always solve for y. Let's move our x term to the other side. So in this first example, I'm going to subtract both sides by 4x. That's going to cancel out here. We're going to be left with 3y equals negative 4x plus 12. Then I'm going to divide each side, every single term, by 3, and we get that y is equal to negative 4/3 x, and then plus 4. And from here, we can identify our slope as the number that's in front of the x. So our slope is m is equal to negative 4/3. Okay, in this example over here, same thing. I'm going to solve this equation for y. So I'm going to subtract 2x from both sides. All right, and I'm going to get negative y is equal to negative 2x plus 5. And because I have a negative y here, that's really like having a negative 1. So I'm going to change that to negative 1 times y. I'm going to divide everything by negative 1. And from here, I'm going to get that y is equal to positive 2x minus 5. Again, we are just identifying our slope. And so our slope m is equal to 2. Okay, and that's how we would do that. The next thing I want to talk about is graphing linear equations. So and actually turning these equations into a graph. So the first thing I want to talk about is our intercepts. So we have x-intercepts, and we have y-intercepts, okay? And this is the location where the graph crosses the x-axis, okay? the y-intercept is the same thing, but it's for the y-axis. So it's the location where the graph crosses the y-axis, okay? And so if I wanted to graph, okay, graph a line with an x-intercept of, say, 3 and a y-intercept of -2. All right, let's go ahead and do that. All right, so if I wanted to just draw a graph, here's my x-axis, here's my y-axis. I have an x-intercept of +3, so I'm going to plot that point here. And then I have a y-intercept of -2, and I'm going to plot that point at -2. And then I'm going to draw our line. All right, so that's going to be really important when we graph linear equations using in standard form. Okay, so let's real quick talk about graphing linear equations in slope-intercept form. So on something like this, we want to sketch the graph of the following line. So I've got the equation y equals 2/3 x plus 1. And what I want to do is identify a couple things. First of all, I want to identify our slope, which is a slope of 2/3. All right, that's the number in front of the x. The other thing I want to identify is our y-intercept of 1. Okay, and so let's graph this, and let's just sketch a graph real quick. So once I have my graph, what I want to first do is plot my point for my y-intercept. All right, so my b value is really also called the starting point. All right, and that's our y-intercept. So if our y-intercept is at a value of 1, I want to go to 1 on my y-axis and plot a point. Now my slope of 2/3, all right, remember this is rise over run. So rise over run, and remember that we have 4 kinds of slope. We have a positive slope, a negative slope, 0 slope, and an undefined slope. All right, because this number is positive, we're going to go up and to the right. So what I'm going to do is I'm going to go up 2 units and then over 1, 2, 3 and plot my next point. All right, and I'm just using this to count and to show you how I'm getting that. But then that's all I need to plot that. I just need those 2 points, and that's a reasonable sketch for my line. Okay, let's look at graphing a line in standard form. All right, so if I wanted to sketch the graph of this line, the first thing that I'm going to do this problem in 2 ways. All right, method 1 is going to be put this into standard, or put into slope-intercept form, okay? And I would do that by solving this equation for y. So I'm at 4x plus 2y is equal to 8. So first thing I would do is I would subtract 4x from both sides, all right? And then we're going to get 2y is equal to -4x plus 8. And then I'm going to divide everything by +2. All right, so I've got that y is equal to -4 divided by 2 is -2, x, and then 8 divided by 2 is +4. So from here, you know, what I have is I now have a slope of -2, and I have a y-intercept of 4. All right, so that's my y-intercept. This is my slope. And so if we wanted to now graph this, then I would have my starting point be at +4. So I'm going to plot that point here. And then I have a slope of -2. So when my n is equal to -2, I want to rise and a run. So I'm going to do -2 over 1. Again, let's draw our little picture. Positive, negative, 0, undefined. So positive, negative, 0, undefined. So our slope is negative, so we're going to go down to the right. So what this means is I'm going to go down 2 units and then over 1. All right, so if I count that going down 1, 2, and then to the right 1, I'm going to plot that point. And we can go up to the up 2 and to the left 1. All right, regardless, that's what we're going to have as our line. Okay, now I want to do this doing a second method. All right, so 4x plus 2y. So 4x plus 2y is equal to 8. Now what I want to do is I want to graph using, so method 2 is use X and Y intercepts. Okay, and so from here, if I want to calculate my X-intercept, then I simply let Y equals 0 and solve for X. All right, for my Y-intercept, okay, I let X equals 0 and solve for Y. Okay, so given this equation, I'm going to do my X-intercept first. All right, so if I let Y equals 0, I'm going to substitute 0 into my equation up here. So I'm going to get 4x plus 2 times 0 is equal to 8. All right, and I'm going to solve this equation for x. Now 2 times 0 is just 0. That cancels out, and we've got 4x is equal to positive 8. All right, and from there, I'm going to divide everything by 4, and I'm going to get that x is equal to 2. All right, the other thing I want to do is figure out our y-intercept. All right, so if I figure out our y-intercept, I want to let x equals 0. So I'm going to substitute 0 into our equation. We've got 4 times 0 plus 2y is equal to positive 8. This cancels out to 0. You're left with 2y is equal to 8. Divide both sides by 2, and we get that y is equal to 4. So now we're back to that same thing that we had done. Let's go ahead and just graph it down here. And so now that we've identified our x-intercept and our y-intercept, I can simply just go up, plot that point for 2, plot that point for 4, and connect those points. And that's the same line that we had graphed over here. All right, so two different ways of graphing equations that are in standard form. The next thing I want to do is write equations given a point and a slope. So let's say that I've got a point that travels through, let's say, -4, 2 with a slope of 1/2. Okay? Now, we can do this a couple different ways. I'm going to first do this using point slope form, which means, if I write down point slope form, that's y minus y1 is equal to m times x minus x sub 1. All right. And when I do this, I want to identify a couple things. I want to identify what my m value is, and that's 1/2. Okay. And then I want to use the point x sub 1 is equal to -4. And y sub 1 is equal to 2. All right, so anytime you got a coordinate value that's an x value and a y value, all right, and I'm simply just going to plug these numbers into my point slope form of my equation, okay? And so what I can do is let's do y minus y sub 1, all right, which is 2, so y minus 2, and that's going to be equal to my slope, which is 1/2. All right, so 1/2 times x minus x sub 1. Now, x sub 1 is equal to -4, so I'm going to put in a -4 here. All right, and one thing that you can do to clean this up is to first by switching the subtracting a negative to an addition. So let's do y minus 2 is equal to 1/2 times x plus 4. Okay, this is in point slope form. All right, well, what we want to do is turn this into slope-intercept form. So the first thing I'm going to do is multiply my 1/2 by everything and solve this equation for y. So I've got y minus 2 is equal to 1/2 times x, so that's 1/2 x, plus half of 4 is going to give us 2. Okay, and so now what I want to do is solve this equation for y. So let's add 2 to both sides, all right? And then we're going to end up getting that y is equal to 1/2 x and then plus 4, all right? And that's our equation that we want to write, all right? So we wrote this using point slope form. I want to write the exact same thing using slope-intercept form. So if I'm using slope-intercept form, I want to use y equals mx plus b, okay? And when I do this, I want to identify my slope an x value and a y value, all right? And so my slope is given to us, and that's 1/2. The x value that we have is -4. The y value that we're given is 2. Now what I want to do is I'm going to substitute these values here into our equation to solve for our y-intercept, all right? And so what I want to do, let's first take our slope, let's take our y value and plug that in. So we're going to write 2 is then equal to our slope of 1/2 times our x value, which in this case is -4. So -4, and then plus b, okay? And what this will do, this equation allows us to solve for b. So now I've got that 2 is equal to, now let's do half of -4, so 1/2 times -4 is -2, and then plus b, and let's add 2 to both sides, and that gives us that 4 is equal to b. So now that we have a slope and a y-intercept, I can take these values, substitute them into y equals mx plus b, and write our equation as y equals 1/2 x and then plus 4, all right? And I want you to notice that regardless of what we do, all right, whether we do this in point slope form or using slope-intercept form, we get the same equation using both, all right? So these two things are the same, and that's the idea. Okay, the next thing I want to talk about is writing linear equations given 2 points. So sometimes the only information that you're given are 2 coordinate points on a graph, and we got to figure out what's the equation of that line. Okay, and we're going to write that in slope-intercept form. So the first thing that I want to figure out is what's our slope equal to? Now remember, we have a formula for that, y2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to come in here and call this x1, y1, and x2, y2. All right, and all that does is tell me what's my first point, what's my second point. All right, let's plug that in to our equation, or to our formula, and we get that our slope is equal to -3 minus 2 over 0 minus 1. And all I'm going to do here is just do the math, all right? And so from here, I've got that my slope is equal to -5 over -1. Now, when I take -5 and divide it by -1, I end up just getting a slope value of +5, all right? And that's my value for m. Now, we can go back. Now that you have a slope and 2 points, you can do either point slope form or slope intercept form. I kind of go through and choose slope intercept form. So I'm going to use y equals mx plus b. Okay, and so from here, I can choose either one of these points. It doesn't matter. I'm going to choose this point for my x and y value. So I'm going to come in here and say that my x value is equal to 1 and my y value is equal to 2. Now, once I have all of this information, I'm going to take these values, substitute them into my formula here, and solve this equation for b. So instead of writing y, I'm going to write 2, and that's going to be equal to our slope of 5 times the x value of 1, and then plus b. All right? And so 5 times 1 gives us 5. Let's solve that for b. So 2 is equal to 5 plus b. Let's subtract 5 from each side, and we end up getting that -3 is equal to b. So now we have a slope and we have a y-intercept. I can now write my equation in slope-intercept form, and I'm going to write y is equal to 5x minus 3. Now, you could have used this as your point, as your x and y value, and you would arrive at the same thing. Now, you could also use point slope form, and again, you would still arrive at the same thing. I tend to choose to want to use slope-intercept form. Okay, the last thing I want to talk about today are parallel and perpendicular slope. Now, let's talk about parallel lines. So parallel, all right, that means that 2 lines run side by side and don't touch. Okay, don't touch or don't intersect. Okay, and what we have to understand is that, say we have the slope of a line, then that slope is like, say, 3. Okay, actually now let's use 2/3. And that means that our perpendicular slope, or I'm sorry, a parallel slope would be equal to 2/3. Okay, so parallel means that the slopes are the same, so the same slope. Okay, perpendicular is where, so perpendicular is where you have two lines that form a 90-degree angle, okay? And so let's say that we had a slope of, say, 2/3. If I wanted the perpendicular slope, that would be a perpendicular, and that's, I'm going to flip my fraction and change the sign. Okay, so we call that the opposite reciprocal. All right, so opposite reciprocal. Okay, and so what that means is that you would flip the fraction and change the sign. Okay, so I know that we've gone over a lot of information in this video, and I'm not touching on everything, but the reason for that is because, again, this is an overview video, and a lot of the stuff you've probably seen before, but you know, all this stuff that you're seeing kind of builds on itself. So if you're being asked questions about parallel and perpendicular slopes and parallel and perpendicular lines, this is how you calculate the slope, and then you have to go back and use those other methods that you have already learned to you know, answer those kinds of questions. So hopefully this all makes sense. Please let me know if you have any questions, and we'll talk to you soon. Thanks a lot. Bye.